Good day everyone. We will discuss about nested loop prefetch in this video. Let's get started. I'm going to use a database called JBSWiki for this demo. I'll be creating a table called table1. We'll have two columns, column 1 integer identity, primary key, and column 2 character 1000. I'll be inserting some random rows onto table 1, and I'll be updating the statistics for table 1 with fullscan. I'll be creating another table called table 2 that has got two columns, column 0, integer identity, primary key, and column 1 integer. Again, I'll be inserting some random rows onto table 2. I'll be creating another table called table 3, which will have three columns, ID, integer identity, primary key, and column 0, character 20, and last column, column 1 integer. What I'll do is I'll be inserting close to 24 rows using the first insert, and this insert will basically have a value of Chennai for column 0, and you will have close to 24 rows of value Chennai as far as table 3 is concerned. And as far as the second insert is concerned, it will be inserting close to 26 rows with a value of Madurai for column 0, and it has got other values also. And the third insert basically inserts close to 200,000 rows of value Trichy on column 0. So once the insert is completed, I'll be updating the statistics for table 3 with fullscan. So what I'll do now is I will create a stored procedure called table 3 proc, and this stored procedure basically has a parameter column 0 character 20, and we'll be selecting column 1 and column 2 from table 3, which will be joined with table 1, and we have table 1 dot column equal to table 3 dot column 1 as far as the join predicate is concerned, and then the normal predicate is column 0 equal to the parameter value. Let's execute that, and then now what I'll do is I will turn on statistics time on, and we'll execute this particular stored procedure with three different parameter value: Chennai, Madurai, and Trichy. So we know we inserted close to 24 rows as far as Chennai is concerned, and 26 rows for Madurai, and 200,000 rows for Trichy. Let's enable the execution plan and then execute the query. The query is complete now. So if I look at the execution plan, it looks simple and sleek, wherein I have an index seek followed by a key lookup on table 3, and then cluster index seek on table 1. The one that I'm very much interested is the nested loop here. So if you look at the properties of the nested loop, and then if you look at it here, there is nothing related to prefetch. That means this particular query where you have this nested loop in your execution plan is having a prefetch disabled. And if you look at the other nested loop also, it will be same, wherein prefetch will be disabled. This will be same for other execution plan also for the other execution. So if you look at it, we don't have prefetch enabled here too. And then the last execution, if you look at that, the properties of the nested loops, prefetch is not enabled here. Yep. So what we understand is we have this stored procedure created, and then we started with a value of Chennai, and then Madurai and Trichy was used later. Now what happened is as soon as we executed this query for the first time, an execution plan was created, and if you look at the estimate here, we basically estimated close to 24 rows here, and then for this particular query, we estimated close to maybe the estimated number of rows for this is close to 24 again, which is 23.9. Yep. And since we created this execution plan based on this parameter value, all other execution, even though we had a huge lot of rows, for example, if you see here, we estimated 24 rows and we returned 26 rows. And also if you look at this one where we estimated 24 rows, but we ended up returning 1,99,800 rows. It is because of parameter sniffing, where we created the execution plan using this value during the compile time, and that was reused for other execution. Now moving on, what I'll do is I will free up the plan cache. Just to remember, I'm on a lab machine, so I'm doing that. It is not recommended to perform this thing in production server. So I'm going to execute these two queries, the stored procedure with different values. That is, it starts with Madurai, and then the next execution will have Trichy. So let's execute it. Now that the query is completed, let's look at the execution plan. Let's look at the estimates here. So we estimated 26 rows and then we returned 26 rows. And also for the cluster index seek, we estimated close to 26, that is 25.9 rows, and we ended up returning 26 rows. Now, if we look at the properties of the nested loop, what we can see here is like the with unordered prefetch is set to true. And if you look at the nested loop here also, it will be enabled. So with unordered prefetch is set to true. Now look at this query execution. So if you look at it, what we can see is like with unordered prefetch is set to true, and this would be same for this query also. If you look at the nested loops, with unordered prefetch is set to true. So let's discuss what is a prefetch. Prefetch is a mechanism with which SQL Server can fire up many IO requests in parallel for nested loop join. When SQL Server estimates less than 25 rows for the outer input table, prefetch will be disabled. So the sweet value here is 25 and above. If it is going to be the estimate, if it is going to be below 25 rows, then with unordered prefetch would be basically disabled. And if it is disabled, then SQL Server basically loses the power to fire up many IO requests in parallel for nested loop join. So if it is a huge query having several IOs fired parallelly is going to be really good for the nested loop join. Yep. So how do we fix this? What we'll do is like we will try adding a recompile hint to that particular statement. Let's execute that. And then now let's execute this particular execution. So we are executing with a value of Chennai, Madurai, and Trichy. So let's execute that. And now, if you look at the execution plan, what we are able to see is like we are estimating 24 rows and we are returning 24 rows, perfect estimate. And here we are estimating 24 rows and returning 24 rows. And if you look at the nested loops here, we don't have the prefetch enabled because the estimation is just 24 rows here. Yep. So now moving on, the second query here, we are estimating 26 rows and we are returning 26 rows. And also here, we are estimating 26 rows and returning 26 rows. And now if we look at the properties here, prefetch will be enabled. So prefetch is enabled. Now moving on, just look at how the execution plan has changed. We are no longer doing an index seek followed by a key lookup, since key lookup becomes costly with a lot of rows. Now we are estimating 1,99,800 rows, returning 1,99,850 rows. And then if we look at the prefetch here, prefetch is enabled definitely here. So what we understand is like now we use the recompile hint. What is happening is like whenever the estimate is less than 24, we were not enabling the prefetch, but as soon as we see the estimation going about 25 rows, we are getting this prefetch enabled. So let's consider this is an very important server and you have this query running several times and there are many other queries that are CPU intensive. So in this case, if you add a recompile hint, the possibility is that like you are going to spend more CPU for compiling the statement each and every time. So let's consider if we don't want to do that. So what we can do is like instead of adding a recompile hint, we can add an hint such as optimize for column 0 is equal to Madurai. So Madurai, we know that the estimate would be 26 rows because we have close to 26 rows as far as this value is concerned, Madurai. So that's the reason I've added this optimize for in this stored procedure as an hint here. So let's execute that. And now what we'll do is like we will execute this stored procedure here with different values here. One thing to understand is like going forward, as soon as I start executing the query, all the estimates will be based on this value here. So for example, let's consider we have a value that I'm going to give in this parameter that is going to return one row. Then what will happen is like we will estimate 26 rows, but we will end up returning only one row. But let's consider we are going to add a parameter that is going to return 1 million rows. Yeah. So in case if we do that, what happens is like it is again going to estimate 26 rows and it will end up returning 1 million row, and we will have a huge performance issue. For at least for this demo, adding this will enable all your nested loops to have prefetch enabled, but that is going to take away the power of optimizer to do the cost-based optimization. And what it will basically do is like it goes with this particular hint that we are adding. So many other things, many other operators like the seek and things like that are going to have a huge impact because of this. So let's execute the query, and let's look at the execution plan. So here we are estimating 26 rows, and then we are ending up 24 rows. So if you note here, we are not estimating 24 rows anymore. Since we have this optimized for value Madurai, we are estimating 26 rows and we are returning 24 rows. And if we see here, we are estimating 26 rows and returning 24 rows. Yeah. Now, if you look at the nested loops, prefetch will be enabled because we have an optimized for, and that is going to be same for the other executions also. Prefetch will be enabled, and now the last one, prefetch will be enabled. As I told you earlier, now if you use this optimized for and use the value of Madurai, it's going to estimate 26 rows. And now we know like the execution plan is not changing from indexy key lookup to cluster index scan, because we are estimating just 26 rows. But anyhow, for this particular demo, we wanted to enable prefetch for nested loops, and we were able to do that. But it is mandatory. We understand like we test all these things on non-production and then move it to production. And also, it is always good to not add hints and allow the optimizer to do its job. But in corner cases, it is always okay to do it, but it is very much required that you periodically check this and see if it is working as expected. That's it for this video. Thanks for watching. Have a great day. Jai Hind.